Worked example number 1 says, Miss Cattell lives on the 13th floor of a building with 15 floors. The only elevator moves continuously through floors 1, 2, all the way up to 14 and 15, and spends an equal amount of time on each floor. So I live on the 13th floor of a building with 15 floors in total. She hopes that when she presses the button, the elevator will happen to be on the 13th floor, so she can get on the elevator immediately. Does this situation seem like a random experiment? Why or why not? So for this, I'd want to go back to my definition of random experiment, which is that we do not know the outcome of the experiment, but we do know the set of all possible outcomes. So is that true for this situation? I don't know what the outcome is going to be. When I press the button, I'm not sure what floor the elevator will be on. But I do know the set of all possible outcomes, meaning the elevator has to be on one of these 15 floors. There's no way that it could be on any floor that's other than these 15 floors. So I'm going to say that this is the set of all possible outcomes, and then what I desire is it for it to be on this particular floor. So I'm just going to label this as my desired outcome. So yes, I know the set of all possible outcomes, yet there's still an element of uncertainty within that. So I know the set of all possible outcomes, however, I don't know exactly what the outcome will be. So there's an element of uncertainty. The outcome is unknown. So the key thing that I'll be looking for in these justifications is that for random experiment, you know the set of all possible outcomes, but the actual outcome itself is unknown. What is the sample space? So the sample space for this particular experiment, the set of all possible outcomes. Again, that's right from my vocab list. So the set of all possible outcomes would be the elevator's either going to be on the first floor, second floor, third floor, all the way up until 14th floor or 15th floor. The set of all possible outcomes. All right. What is the probability that the elevator will be my desired outcome? The elevator will be on my floor, the 13th floor. So the probability that the elevator is on the 13th floor, I'm going to use my equation for probability, which is number of desired outcomes divided by number of possible outcomes. In this case, there's only one floor that I want the elevator to be on. I want it to be on my floor, obviously. So that's one desired outcome out of the possible 15 floors that the elevator could be on. So that's 1 over 15. And then I'm going to divide that in my calculator to get a percent as well. So 1 over 15 gives me the decimal of 0.06666. If I multiply that by 100, or I move the decimal place over 2 times, that's going to round up to the nearest whole percent of 7%. So I have about a 7% chance of the elevator being in the place I want it to be, which is not that great. It's much more likely to not happen than it is to happen. So I'm likely to have to wait for the elevator in my building. What is the probability that the elevator will not be on the 13th floor? In your answer, use the appropriate notation. So because I'm looking for the probability of something not happening, I'm looking for a complementary probability. What's the probability the elevator is not on the 13th floor? In this case, there's 14 possible floors that the elevator could be on that are not my desired outcome, that are not the 14th floor, that are not the 13th floor, out of 15 possible floors the elevator could be on. if I divide that 14 over 15, I'm going to get about 93%. That should not be a surprise because these two probabilities, the probability that it will be on the 13th floor and the probability it will not be on the 13th floor, should add up to 100% because they're complementary probabilities. All right, lastly, what is the probability the elevator will be on the 12th, 13th, or 14th floor? So for this last one, the key word is an or. Whenever we see an or, we're talking about like multiple possible outcomes that are desired. So we're always going to be adding. You're going to get very used to that. Whenever you see the word or in probability situations, it's always some sort of additive property to the probability. So in this case, the probability 12th, 13th, or 14th floor. In my head, I could just, for this particular problem, you could just add 1 plus 1 plus 1 and know that it's going to be 3 over 15. But just for the sake of this problem, what we're actually doing is we're taking the probability of the 12th, which is 1 over 15, plus the probability that we're on the 13th, which is also 1 over 15, plus the probability we're on the 14th, which is 1 over 15. So the probability of those 3 floors all happening, I'm fine with any of these 3, I don't care. So I actually have 3 possible chances of getting what I want out of a total of 15. So the more desired outcomes I have, the more likely something is to happen in my favor, which makes sense. So I have 3 over 15, which is going to give me exactly a 20% probability of falling on one of those 3 floors. So I'd say the key point here, let's just annotate our work so you guys can refer back to this. We know that this 1 over 15 would be, this alone would just be the probability of the 12th. But then we're adding it to this 1 over 15, which is the probability of the 13th. And then we're adding it to the last probability of the 14th floor. Hi, Kathy. Yeah, what's up?